Hi, I'm Camille,
I'm David.
and this is the Catchy Tune Catastrophe. So for our world, we created a catchy song that a ninja would have written, and we wanted to see what would happen if they shared it with the first year class. We assumed that they would share it with one table in one studio every day, assuming that we had class every day. And we wanted to see if by the end of the month, the song would have caught on, which would mean that 50% of the class would be a devotee, which we will explain later.
And so other than just calling it like a catchy song, this actually does relate well to the models that we've been learning about. So we modeled our system after the SIR model for multiple reasons. One of which is that we have aggregate groups who only move forward. And so as with the SIR model, we had susceptible, then infected, then resistant. In this model, we have people who have never heard the song, people who've heard the song once, people who've heard the song twice, and so on after that. And people can only move forward and not backwards. Another thing is moving between the two groups we have different rates. And so with the SIR model, there was the rate of contact and the rate of infection. And with this, we have rates that are based off of parameters that we set to make it more realistic. And then that's also combined with the population of the groups.
For our model, we had 5 groups: never heard, exposed, familiar, admirer, and devotee. So never heard represented having heard the song 0 times, as it says, and then you would hear it one more time as you go on through the groups, ending with devotees who have heard it 4 times. The arrows below the boxes represent the ninja rate, which is the constant 1/21st of the population that the song is being played for. And then from the devotee box, we see 4 arrows corresponding to the other boxes, which represent the share rate, which is how many people a single devotee would share the song with. So the more devotees there are, the more people the song is being shared with. And we also said that as you go up in the amount of times you've heard the song, you'd be more willing to have the song shared with you again. Therefore, the percentage of people that it was shared with went up 1% for each group, going from 7% in admirer to 8% in devotee, for an example.
So our results really line up with how this model is working based on the rules that we gave it. It makes sense that never heard declines sharply at the beginning and then levels off at the end, because initially it's the only population who's being impacted by the ninja playing the song. We look at exposed, which is the group of people who have heard the song one time, and that has a sharp increase at the beginning because that's the only group that people are moving into. As we move along the system, those 3 groups in the middle kind of level out, and the devotees start to be the ones who take up most of the population, and that's because everybody is filtering into that one group. And as that group grows, the rate at which it grows as well.
So in conclusion, our tune does not catch on by the end of the month. It falls short by 5 students and only hits 40 first-year students as devotees. Some things that we had to simplify in our model in order to be able to represent it with our coding knowledge was that we use percentages to identify interactions between people. So we made sharing between people into a percentage, which wouldn't necessarily be as constant as we used in our model. And also we assumed that hearing the song would mean listening and identifying the song as well as liking it. We assumed that a catchy song would be catchy to everyone. But overall, our model did a good job at representing how a song would catch on within a class based on a share rate of the ninja and as well between people, and did a good job at showing how those interactions would pan out for a catchy tune. Thank you.
Thanks. Boom, boom, boom. Pow.